Now, the last class actually, the last AV rather, I should say, the current went off. So I have to stop in the middle. You can see that abruptly I have to stop. So what I was saying, that may continue from there itself. That I was talking about, suppose we are having a tri basic acid like Na3PO4. Na3PO4 is made up of what? Phosphoric acid. NaOH and phosphoric acid. Phosphoric acid is nothing but a tri basic acid. So Na3PO4 is a salt of tri basic acid. We can say that. So what you find is that if I take Na3PO4, it will dissociate to give you Na plus in the first step. That is Na plus, and that is nothing but H3PO4 3 minus. We can say that. Or if I take H3PO4 also, that is what I was saying in the last class to you, in the last AV to you, that is H3PO4 will dissociate to give you, same like Na3PO4, it will dissociate to give you, that is H plus and H2PO4 2 minus. We can say that. Clear? So, next is in the next step, in the first step we got it this. In the second step, what you will find is that you will be getting 2 H plus ions. It will dissociate to give you another H plus and HPO4 minus. In the third step, what you will be getting is that it will be getting, that is H plus and PO4 3 minus. So what you are getting is that is you are getting 3-step reaction it is. In the first step, we can say that it will be the equilibrium constant will be Ka1. For the second step, for the dissociation of the second H plus ions, it will be Ka2, and for the dissociation of the third H plus ion, it will be Ka3. So, total equilibrium constant for that particular reaction will be K is equal to Ka1 into Ka2 into Ka3. Alright, total equilibrium constant for the reaction will be K, which is equal to Ka1 into Ka2 into Ka3. What I was saying you. Same thing for a base also. Alright, that is for triacidic base. This was, I was talking to you about tribasic acid. Now triacidic base, let us say. So in that case, what you will find, like triacidic base, like you will be getting that is nothing but FeOH whole thrice, we can say that if you take it. Clear? Or AlOH whole thrice, you can say that you will be taking it. So it will dissociate to give you first 1 OH minus ion, then you will be getting 2 OH minus ion. In the second step, it will give you 3 OH minus ions. We can say that. Alright, when it reacts with acids, and so to say, we can say that. Clear? So hence, what you find that in case of triacidic base, their Kb, equilibrium constant Kb for the entire reaction will be Kb1 into Kb2 into Kb3. So whatever in short, whatever I want to say is that whether it is a diacidic or triacidic or dibasic or tribasic acid, whatever it is, I am taking it. So total equilibrium constant is a product of the equilibrium constant of number of reactions. Suppose if it is 2-step reaction, then K is equal to Ka1 into Ka2, or K is equal to Kb1 into Kb2. If it is a 3-step reaction, if it dissociates completely into 3-step, then I said you earlier also, that is K is equal to Kb1 into Kb2 into Kb3, or K is equal to Ka1 into Ka2 into Ka3, in this way. So we calculate the equilibrium constant for a particular reaction, so to say. Now we will come to the next one is your nothing but ionization of water. Alright, which is denoted the letter Kw. Like for acid dissociation constant, we have got Ka. For base dissociation constant, we have got Kb. So when water dissociates, it is nothing but known as Kw. So we are going to study ionization constant of water, which is nothing but denoted with the letter Kw. We can say that ionization constant of water, so to say. Now here we will consider that water dissociates feebly. You know that pure water does not dissociate. But here we will be taking not pure water, that is distilled water, we are not going to take it. We are going to take potable water, means drinking water, we can say that. Now do you know drinking water contains some mineral salts present in it, and due to the presence of mineral salts only dissociates very feebly. Mind it what I am saying you. That is, it is potable water, it is drinking water, it is not pure water, because pure water is a non-electrolyte, distilled water is a non-electrolyte. See, if you pass electric current through it, it is not going to dissociate at all. But potable water or drinking water, it dissociates to a certain extent, that is small amount it dissociates. So, when I am taking, that is nothing but water, that is potable water, then it will dissociate to give you H plus and OH minus ions, we can say that. or if you take H plus water, it will give you nothing but H3O plus ion. So there is no difference between H plus and H3O plus. The only difference is that H plus is hydrogen ion and H3O plus is hydronium ion. The only difference is that this is more stable in nature than this. This is stabilized by resonance, this does not. That's the only thing. Got it? So better is to write H3O plus because it is quite stable compared to H plus ions. Now, next is if I calculate the equilibrium constant, that is K, for this particular reaction, the first reaction we consider that. Then what will be getting? That is K is equal to concentration of H plus into concentration of OH minus by concentration of water, isn't it? That is equilibrium constant K. That is concentration of product by reactant. Now K into concentration of water. Now you know generally concentration of water remains constant, isn't it? So it will be what? H plus concentration into OH minus ion concentration. So K into concentration of water will give you what? It is nothing but going to give you Kw. This will give you Kw. The symbol is K into concentration of water. Generally water concentration is 1 unity. So nothing is going to change. Value is not going to change at all. Just the symbol is changing. K into concentration of water is what? Kw. Got it? So Kw is what? Concentration of H plus into concentration of OH minus. This is the formula we got it. Now if you will say no sir, I will take it H3O plus. Instead of H plus, I will take it as H3O plus. So what it will be the formula? Kw is equal to concentration of H3O plus into concentration of OH minus. There is no difference. There is no difference. Alright. Now the value of Kw, this you got it the Kw. This is ionization constant of water or ionic product of water also. We call it as ionic product of water also we say, or ionization constant of water. Whatever you like, you can say that. Now there is a particular value for ionic product of water. We can say that. What is that value? It is 10 to the power minus 14. 10 to the power minus 14. The value of Kw is. The value of Kw, it is 10 to the power minus 14. We can say that. 10 to the power minus 14. How do we get it? This is maximum value, it can be 10 to the power minus 7 for H plus. Similarly, for it, this also OH minus is 10 to the power minus 7 because water is neutral in nature. The total pH value, I am going to tell you pH. Got it? Is what? 14. The pH paper range is 14. So up to 7 is neutral. If a substance is neutral, the pH value is 7. We can say that. So 10 to the power minus 7 up to 7 values, it is H plus. Same value will be OH minus also. Same value will be OH minus. Got it? Because always a pure substance, what you can say, a neutral substance dissociates into same number of H plus ion into OH minus ions. Alright, for example, water. Here the neutral substance is water. Dissociates into same concentration of H plus ion into same concentration of OH minus ions. In case of any other neutral substance, it will have same number of what you can say positively charged ions and the same number of negatively charged ions. Alright, apply the common sense. If the number of positive and the negatively charged ions will differ, alright, if the number of positively and negatively charged ions is going to differ, then will it be neutral? Let us say H plus ion is greater than OH minus ions, it will be acidic. If it is OH minus ion is greater than H plus ion, it will be basic in nature. Got it? So here, in case of neutral substance, the concentration of H plus ion is same as the concentration of OH minus ions. So here the concentration of H plus ion is 10 to the power minus 7, OH minus ion is 10 to the power minus 7. So 10 to the power minus 7 into 10 to the power minus 7 will give you 10 to the power minus 14. So the value of Kw is 10 to the power minus 14. We can say that. Alright, remember it. The value of Kw is 10 to the power minus 14. Now if I calculate pKw, pKw is nothing but minus log Kw. pKw is minus log Kw. Alright, P stands for power or potence. P stands for, what does the P stands for here? P means power or potence. Potence of what? Suppose if I take H plus ion, in case of pH, it will be power of H plus ion. If I take OH, POH, then it will be power of OH minus ions. If I take pKw, it will be power of Kw, ionic product of water or ionization constant of water, we can say that. Got it? So hence, P is nothing but minus log. So minus log 10 to the power minus 14. Let me rub it this one. Already I have read it this one. So 10 to the power minus 14. That is minus log 10 to the power minus 14. We can say that. So minus of minus, it will be plus 14 log 10. What is log 10? 1. So it is 14. So pKw is equal to 14. We can say that. pKw. Kw is 10 to the power minus 14. pKw is 14, we can say that. In this way, we got that is the value of pKW. Also, we got the ionic product of water, which is 10 to the power minus 14. Now, next is there are certain factors upon which the ionic product of water depends, and there are certain factors upon which it does not depend. First of all, ionic product of water depends upon temperature. If the temperature is increasing, listen carefully, if the temperature is increasing, then definitely more of H plus and OH minus ions will be increasing. Alright, it is generally it is being seen that when we increase the temperature, that is H plus and OH minus ions, dissociation slightly increases. I don't say it increases to a large extent. Slightly it increases, slightly. Whatever it is increasing. So the value of Kw also changes. The value of Kw also changes. Means if water is at room temperature, then this will be the value of Kw, 10 to the power minus 14. But if the water is heated, slightly it is heated, then what you will find is that the H plus and OH minus ion concentration changes, due to which the value of Kw also changes. Alright, so value of Kw depends upon temperature. This is the effect of temperature on the ionic product of water. Now, next is you find the ionic product, as I said, it increases with increase in temperature. So next is we will see, if you add an acid to water, will the Kw change? If you add a base to the water, will the value of Kw change? Let us see what it happens. Alright, let us see what it happens. So, if I am going to add an acid to the water, what is going to change? If I am going to add a base to the water, what is going to change? So, first we will see for the acid. Now, water, it is nothing but concentration of H plus into OH minus, so to say. Now, when I am adding an acid, HCl, so it will be H plus and OH minus ion concentration. Alright. So, what you find is that H plus ion concentration here it is more. H plus ion concentration is more. If the concentration of the product is more, you already did Le-Chatelier's principle. The equilibrium will favor in backward direction. Backward. You will say, why sir it is not favoring in HCl? HCl is again a strong electrolyte. If at all the equilibrium is favored in HCl, then again HCl, as it is a strong electrolyte, it will dissociate again into H plus and what you can say Cl minus. Sorry, this one is Cl minus. I am very sorry, it is Cl minus. Alright, it will again dissociate to form what? H plus and Cl minus. We can say that. Again it will dissociate because it is strong electrolyte. It will dissociate completely. So hence the equilibrium, if it is favored in this way, no change. But if it is favored towards water, what you will find is that is the concentration of water is increasing. Understood why? Again I repeat. This is water. It dissociates into H plus and OH minus. I have added some acid to the water. Let us say I am adding a strong acid, HCl. By adding strong acid, H plus ion concentration you can see is increasing. As H plus ion concentration increases, means the concentration of the product is increasing. Equilibrium will favor in which direction? Backward direction. We have read it already in Le-Chatelier's principle. Equilibrium will favor in backward direction. So backward direction, what is that? Water. You will say, why not HCl? If at all, let us say HCl I am taking. Let us say HCl I am taking it. So HCl again will dissociate to give H plus and Cl minus. Why? Because it is a strong electrolyte. Strong electrolyte always dissociates completely, and strong electrolyte after dissociation does not recombine. Alright, remember it. Strong electrolyte after dissociation does not recombine, because if it recombines again it will dissociate. So what is the use? So hence for that particular purpose, here as the concentration of H plus ion is increasing, the equilibrium will favor in backward direction. Backward direction, what is there? Water. What is the concentration of water? 1. So will the value of Kw change? No. The value of Kw remains as it is. Got it? And value of Kw remains as it is, because concentration of water is always 1. So value of Kw remains as it is. Again I repeat, I am adding HCl. H plus ion is increasing. Due to Le-Chatelier's principle, the equilibrium is favored in backward direction. As the equilibrium is favored in backward direction, what happens is that the value of Kw remains, that is same. Now this particular term is also called as common ion effect. This is called as. Here we will be using a term here known as common ion effect. Got it? Common ion effect. Now what is common ion effect? What is common ion effect? You can see it here very clearly. Common ion effect. That is when one ion is common between the two, what you can say, equations. That particular ion is called as a common ion. And due to common ion effect, the degree of dissociation is suppressed. Alright, common ion effect is the effect in which the degree of dissociation decreases. Alright, degree of dissociation is suppressed, degree of dissociation is increased. What you can say, it is degree of dissociation is decreasing. Why? Because equilibrium is favored in backward direction. Try to understand. This is known as what? Common ion. See, this ion is common, so it is known as common ion effect. So due to common ion effect, what happens is that, what I said, degree of dissociation is suppressed, degree of dissociation is decreased. Why? Because the equilibrium is favored in backward direction. Alright, so common ion effect is an effect in which the degree of dissociation is suppressed, degree of dissociation is decreased. Alright, fine. If you add a base, a strong base like NaOH, here also same thing, common ion effect will come into play. You can see Na plus plus OH minus. See here, OH minus and OH minus. Again, it is a common ion. So again, if you add an acid, the equilibrium is favored in backward direction. If you add a base due to the increase in concentration of OH minus ion, again the product, again the common ion, the equilibrium is favored in backward direction. So backward direction is what? Water. Alright, what is the concentration of water? It is 1 unity. We can say that. So value of Kw remains same. The value of Kw remains same because Kw is K into concentration of water. So water concentration is 1. So value of Kw remains the same. So value of Kw does not change with the addition of small amount of, mind it. Here also I am adding this word, small amount of acid or base to it. If you add a large amount of acid or base, definitely the solution is going to become acidic or basic. No doubt in it. But if you add a small amount of acid or base to the water, then the value of Kw does not change. It remains as it is, we can say that. The value of Kw does not depend upon what you can say, the addition of acid or base. But the value of Kw changes with the change in temperature. That is, increases with increase in temperature. So I think you understood what is Kw, so to say. That is ionic product of water. Next we are going to come to pH. What is a pH? pH means it is a negative logarithm of hydrogen ion concentration. That is, it is a negative logarithm of hydrogen ion concentration, that is called as a pH. Negative logarithm. What I said, pH is nothing but minus log base 10 H plus ion concentration. That is called as a pH. It is a negative logarithm of hydrogen ion concentration. So that is called as a pH. Negative logarithm. Fine. Now next is what is H plus ion concentration then? It is nothing but 10 to the power minus pH. Definitely. This is in the logarithmic form, the equation is, this is in the exponential form, I have done it. Alright, so H plus is 10 to the power minus pH. Similarly, we have got POH. POH is what? Minus log base 10 OH minus ion concentration. POH is negative logarithm of hydroxyl ion concentration. It is the negative logarithm of hydroxyl ion concentration. So what is OH minus ion concentration? It is nothing but 10 to the power minus POH. 10 to the power minus POH. We can say that. Clear? It is the negative logarithm of hydroxyl ion concentration, and OH minus ion concentration is 10 to the power minus POH. Alright. Now, next is we will see what is the relationship between pH and pH. Now, one thing I think you must be knowing this particular thing. That is the pH of neutral substance is 7. If it is below 7, then the solution becomes acidic in nature. More and more and more and more of acidic. Similarly, if the pH value is increasing from 7 to 14, then what happens is that the basic character is increasing. I hope you know this particular thing. Alright, yes. Now, next is what is the relationship between pH and POH? We can say that. We will come to it. So, just now we studied that Kw is equal to concentration of H plus into concentration of OH minus. Now multiplying minus log base 10 throughout in both the sides. I am multiplying. So it is minus log base 10 Kw minus log base 10 H plus into OH minus. So log A into B is what? Log A plus log B. So minus log base 10 H plus minus log base 10 OH minus ion concentration. What I said, if I multiply both the side minus log base 10, so it will be minus log base 10 A into B. So minus log base 10 A into B is what? Minus log A minus log B. Alright. So what is minus log base 10 H plus? It is nothing but known as pH. And what is this? It is known as POH. And what is minus log base 10 Kw, it is pKw. pKw is what? 14. 14 is pH plus pOH. So this is a very important equation. If you know the value of pH or pOH, got it? If you know the value of pH, you can calculate pOH. If you know the value of pOH, you can calculate pH. It's very important. This equation is, that is pH plus pOH is equal to 14. We can say that. Similarly, we will see this. We got it. The relations between Kw, Ka and Kb. The relationship between Kw, Ka and Kb. Got it? Now I am saying the relationship to you. Got it? It is nothing but pKw is equal to pKa into pKb. Got it? pKw is equal to pKa plus pKb. pKw is equal to pKa plus pKb. That means pKa plus pKb is equal to 14. Now this you will derive it and you will show it to me. Alright, what I said you, pKw is equal to pKa plus pKb. So what is pKw? It is 14. Just now I said you. So pKa plus pKb is equal to 14. So this equation you will derive it and show it to me. You will start from Ka is into Kb is equal to Kw. I am giving you a hint also. Ka into Kb is equal to Kw. I gave you a hint. From there you will start and you will be getting it as a result. We can say that. Clear? So this is about your ionic product and pH. Thank you.